So looking at question 17 out of 8-4, says use the 50 service times for McDonald's during dinner times in data set 25 to complete the following. Assuming that dinner service times at Wendy's have a standard deviation of 55.93 seconds, use a 0.01 significance level to test the claim that service times at McDonald's have the same variation as service times at Wendy's. And then the interpretation question, should McDonald's take any action? So we'll address that after completing the hypothesis test. So first thing that we're interested in here, what is the claim? And the claim is that McDonald's standard deviation, its variation is the same as that of Wendy's. The opposite or negation of that is that the standard deviation is not equal to 55.93.
Oh, and ask what machine? Oh.
So moving over to write our hypothesis statement, sigma in the claim, sigma in the hypothesis statement. 55.93 in the claim, 55.93 in the hypothesis statement. And for the null hypothesis, not even looking over at the claim and the negation, every single time in the null hypothesis, without exception, is the equal case. What we do look over here towards the claim and its negation is for the strict inequality. And our strict inequality here is the not equal. So next we'll do the R and the S, and we'll look at which one looks most like, if not identical, to the claim. And that is the null hypothesis. So we're going to star the R there. And now we can move in identifying what information that we can get from this. The tail of the test, we look at the inequality in the alternate. This is a two-tailed test. When we go to statdisk and choose the alternative, we want the not equal case. That's why we're identifying it now, so it's kind of in our consciousness when we get there. Our significance level is alpha, so again, we're using a 0.01 here. And in terms of the statistics, well, we really weren't given anything other than the sample size. We were told to go to the raw data. So we don't have to go ahead and worry about that here. If we're using raw data, we'll get to that when we head over to statdisk. Usually the idea of everything that we're doing in these first three steps here is to set the stage to use technology, get our results, then make our decision. Our rule of rejection will always start out as reject null hypothesis if p-value is less than or equal. And the only thing that ever changes is what number ends up over here. So at this point, we're ready to go to statdisk to figure out what chi-squared is, as well as its associated p-value. So I'm going to switch over to statdisk, get rid of the previous information, and they said we wanted data set 25, and we want to use the McDonald's dinner times. So again, it's a test of one standard deviation. So hypothesis testing, sample standard deviation, one sample. And in our top portion here, it was a two-tailed test, not equal. Significance level was 0.01. Claim standard deviation, 55.93. And at this point, we're ready to head on over to the Use Data tab. And we want the McDonald's dinner time. So from there, we can just go ahead and hit Evaluate. And as always, go ahead and hit the plot there. And what we can see in the plot is this is a two-tail test. And our test statistic, the blue vertical line, does not fall in the tails. It falls in the middle, which means that we've got a result that's consistent with the null hypothesis. And let's go and take this window back over to OneNote here. Let's make that a little bit bigger. So there's our test statistic. There's our p-value. So our test statistic is 62.049, p-value 0.1996. So is basically 20% less than 1%. No, it is not. We fail to reject the null hypothesis. And when we fail to reject, we don't have the evidence. We have insufficient evidence to reject the claim that too much imagination to see that as a that. Now, if I write this poorly on a giant 27-inch screen, imagine how badly I do on a regular one.
I have found that you have to set your tablet just right, Gary.
And let me see if I can get this a little bit more horizontal, if that helps. Reject the claim that the service times at McDonald's have the same variation as Wendy's. I'm going to use a little bit of instructor prerogative there and cut that. So we put this together in 3 pieces. Now let's go back and read it all the way through. We have insufficient evidence to reject the claim that the service times are the same. So if we can't say that they're not the same, we just have to go under the idea that they're the same. They might not be exactly the same, but we don't have enough evidence to say that they're different. So as far as we're concerned, the standard deviation of McDonald's dinner time, service times, is comparable, is basically the same as that of Wendy's. So next, should McDonald's take any action? Well, this is
no, if we fail to reject it. Well, actually.
So one of the, and this is where knowing the context of what's going on makes a question like G a lot easier to answer. If you worked for McDonald's, you would kind of know what it is that you're hoping to see. Now, since I don't, I'm just going to try to use a little bit of logic here and think about what McDonald's would probably like versus what they wouldn't like. And again, this is variation. It's not how long people are waiting, it's the spread of how long people are waiting. So I would think that McDonald's would want to be comparable to their competition, if not more consistent. So if their standard deviation was less than it, they'd probably be happy. If it's the same, yeah, they would probably be happy. If it was greater than, then they would probably look into, can we do something to offer more consistent service? But since the results appear to be comparable to their competition, I can't think of any reason why they would need to take any action here. See any flaws in that logic, Mark, or anything else on your side?
No, the only thing, like, and I'm glad you went kind of down the wire there, but what I have a lot of students do in this scenario is they make the decision about should a company or should an organization take action based on whether or not we rejected or failed to reject the null. And like Gary pointed out, it isn't as simple as that, right? We have to go down into the context and determine what we mean by saying that McDonald's service times are theoretically the same as in terms of their variation as Wendy's service times. So it's not just making a decision based on whether we're rejecting or failing to reject the null. It's based on context of the problem at hand.
Yeah. Typically, since the null represents the status quo, typically if you're failing to reject the null, you're probably not going to be taking any action. Probably not. No guarantees in life.
Sure.
Because in a scenario, maybe you wanted to increase sales. And if you hadn't increased sales, then, you better get to work. But, in this particular case, if we had rejected the null hypothesis, we'd have to go back and look to see what side of 55.93 did our sample results fall on. If they were on the high side, that would mean that it was less consistent. If it was on the low side, it was between 0 and 55.93, and we rejected the null, that means McDonald's service times are more consistent. Don't mess with what's not broken there. So in that case, rejecting the null hypothesis doesn't guarantee that you're going to be taking action. It's only on one side of it that you'd want to take action. The other side, uncork the champagne.